Okay, so we're going to talk about linear regression. So linear regression is the simplest type of regression that there is. It involves one independent variable, which is x, and then there is another dependent variable, which is y. So this is independent and y is dependent on x and other factors. If y, that is a dependent variable, is dependent on more than one variable, then it's called multiple regression, but we're just focusing on simple linear regression here today. So let's just write the simple linear regression model equation. So the regression model, just the simple linear regression model, the equation is given by y is equals to beta naught plus beta 1x plus epsilon, which can also be called e or error term. In here, beta naught and beta 1 are parameter terms, or just parameters. X is the independent variable, y is the dependent variable, and epsilon here is the error term, which accounts for everything that x cannot. The simplest example of this model can be, let's just say we are talking about the sales of a store which has multiple branches, multiple chains at different cities or different countries. So x here will just be one particular restaurant in one city, and then y will be just the sales of that restaurant in that city. So we just put in x and then we find the value of y, and what all other terms are there which affect the value of y will just be error, right? So that is what a regression model is. Now, since there are different restaurants, each restaurant is going to have expected value of sales, which is expected value of y here. So that expected value we denote by e of y, which is just expected value of y. So the equation that gives the relationship between x and the expected value of y is called simple linear regression equation. So simple linear regression equation, it is different from simple linear regression model. So the expected value of y is equals to this. If we plot this, it is going to be a straight line with b naught as the y-intercept, or just the intercept, and beta 1 is going to be the slope of the line, and our EVA here is just going to be the expected value for a given value of x. So in reality, we don't actually know the values of beta naught and beta 1, because that would be the perfect model or the perfect equation here. So if we put the values of beta naught and beta 1 in the regression model and in regression equation, we would have the true values. But in reality, we don't actually know those values. So that's why we have a sample statistic, which we're just going to denote by b0 and b1. And these are just going to be the estimators of beta naught and beta 1. And these are just estimators. So if we substitute the values, these ones, beta naught and beta 1, in this equation, what we will get is so this equation here is just called the estimated simple linear regression equation. So it's estimated. So anything that is estimated, we put a hat on this here. So this hat represents, so like b naught can be considered as beta naught hat, b1 can be considered as beta 1 hat, but just for simplicity purposes, what we're doing is we're just calling it b0 and b1, so that we don't have to write that hat thing every time. So this is the equation. So it's called the estimated simple linear regression equation. In correct terminology, what we say is that y hat here is the point estimator of expected value of y which is the expected number of sales at one restaurant, and then beta naught and beta 1 are the point estimators of beta naught and beta 1, which are the actual parameters in a true model. Now the whole process of getting a regression model, like how it works is, in the beginning we have sample data, right? So we know that we have some restaurants, we can collect data from previous years and see that for like x and y values, x1, x2, and then y1, y2. So x could represent the number of population of that city, and then y could be the number of sales for that city, considering that there is one restaurant in one city. So this can go on, then we would have x and y, and so we originally have like a collection of data x and y which we can use to train our model, and then going from there. Second, we find the estimated regression equation. That's the second point. So because we don't know the actual model, that is what we're trying to get, right? So we can just make an estimated equation which is y hat is equals to b0 plus b1x, and these are all just point estimators of the expected values, right? From there, so these are all point estimators, they're not the actual values, we're just trying to guess them. And then the third step, b0 and b1, like we calculate them to get actual values of the point estimators. And the last step is that we get the actual model, not the equation but the model, right? So this will be the model, and expected value of y beta naught plus beta 1x, this will be the regression equation, and then like we'll have these parameters. So that's the whole estimation process for simple linear regression. And in the next video we will see how to find the estimated regression equation using something called least squares method.